Let me just check some here. All right, guys, we are on. All right. People online can see the screen and hear clearly. Just checking. Hello. All right, that's it. All right, go let's go. All right, guys. So let me this. All right, so we want to work through this paper. All right, and you're gonna grade yourself as we go. Remember, the whole idea is to find your mistakes and learn from them. Right? Identify your mistakes and learn from them. If a question get wrong, that we're gonna do it over. It's the whole idea. All right. So I'm gonna work from number 1 and all the way back to the last question. Normally we start at the back, but I'm gonna work from number 1. I'm gonna push through. All right. So number 1 is our calculator question. Use a calculator to work this out. So all we need to do is put this in the calculator exactly as it appears here. Fraction, and on top of a mixed number, stop talking. Hey, stop talking now. A mixed number, 2 1/4 minus another mixed number, that's 1 3/5 divided by 3. And I want the exact value, so don't give them that decimal, give them answer the fraction. That's 13/60. All we have to do is make sure that what we put in the calculator is exactly what we have on paper, which it is. All right, so that's 13/60 is the answer. That is it. Next question is for us to calculate this thing and give the answer to 2 decimal places, basically. Make sure the calculator is in degrees, which is the DEG at the top of the calculator there, means that it is in degrees. Make sure the calculator is in degrees. So it's 2.14 times the sine of 75 degrees, and that is equal to 2.067081, and so on. But I want it to 2 decimal places. So these are your 2 decimal places. You're going to use this 7, correct those 2 decimal places, and so it becomes 2.07. Because the 6 is increased by 1%. That is the answer to 2 decimal places. Very good. Next question. It gives us this table. It's kind of a payroll consumer arithmetic kind of question. It says, Irma takes home this amount of money, $4,320 every fortnight. A fortnight is 2 weeks. So every 2 weeks, she's taking home this amount of money every 2 weeks. So each fortnight, Irma allocates according to the table below. So this is how she spends the money. And we see we have the 4,320 total, but this is expressed in terms of X. Those two are expressed in terms of X. Guess we have to calculate the value for X. He said, what is Irma's annual take-home pay? And we have to assume that there are 52 weeks in a year. So there are 52 weeks in a year, and she gets paid per fortnight. 52 divided by 2. Remember, there are 2 weeks in a fortnight. So if there are 52 weeks in a year, then there are 52 divided by 2, which is equal to 26 fortnights in a year. Agreed? So all we need to do is calculate her take-home pay and multiply by 26 to get the annual take-home pay. But understand that. Good? So the annual take-home pay, and this was our take-home pay, let me see. So she takes home, right? So this takes home this per fortnight. So this is amount times 26. So the annual take-home pay, annual take-home pay, going to become 26 fortnights in a year times the amount that she takes home, which is 4320. That is it. As simple as that. 26 times 4320. So she's taking home 112,320 per year. That's what they take home per year. Annually, right? Then it says, determine the amount of money that Irma allocates for rent each month. That she allocates for rent each month. So what we're gonna do is find out how much you allocate for a fortnight for rent, that is the X. Then we're gonna have to multiply by 26 to get the annual figure, and then divide it by 12 to get the monthly figure. But understand that. I don't want it per month. Yes, that's what we have to do. We cannot assume that it is 4 weeks in a month here. Right? You can assume that it's 2 fortnights per month. You're gonna have to say they want us to report in annual. So we're gonna have to report the annual rent amount and divide it by 12 to get what the monthly fee is, the monthly rent is. But let's work out these X values first. We're gonna need these X values. So we're gonna get these X values. You can do the calculation here. I didn't actually ask us for the X. Let's work them out and put them on the table right here. Because we're gonna need them. This is the amount for rent, which is X. So to get the amount for X, we're gonna add up all of this and put it equal to this, right? So if you do the calculation right here, we're gonna get X plus 2X is 3X. Plus this amount of 629 plus this amount of 1750, and that's all equal to this amount down here, the 4320. So to find the 3X is going to be 4320 minus these. So it's 4320 minus the sum of those two, which is 629 and 1750. And subtract it. All right. So the 3X becomes equal to, let's write that out. I'll divide by 3 afterwards to get X. Let's write this out. So it becomes 4320 minus the sum of 629 and 50. Right? So that is 1941. And then X becomes E. So it is 1941 divided by 3. That is the X. So X is equal to 647. We also need a value for 2X. So 2X is 2 times that. So we're going to multiply this by 2 now to get the 2X. So the 2X is 1294. So we can put these on the table now. So this value is actually 647. And this figure is actually 1294. So this is our rent per fortnight. 647. So that's the one I have to find out the yearly rent and then divide it by 12 to get the monthly rent. All right? But I want the monthly rent each month. So the rent per fortnight is equal to $647. $647. Therefore, rent per year is 12, not 12, 26. It's 26 times 647. So I'm going step by step for you. Can be much quicker than this, but I'm doing step by step. So it's 26 times 647. So this is our rent per year. Therefore, the rent per month that 12 months in a year is 16,822 divided by 12. So if we divide that by 12, and so it becomes 1,401.83. That is the answer. I get some persons, they just multiply it by 2, the fortnight figure, assuming that 2 fortnights make a month. As in the real world, sometimes that's the case, but that in all cases, there are some months that actually have 5 weeks in it. Right? So it's not a straightforward month. So with the 647 by 2, you're actually getting 1294. But you have to do the annual figure by multiply the fortnight, rent amount by 26 to get the annual figure, and then divide that annual figure by 12. Huh? Why multiply by 26? Because remember, it's 26 fortnights in a year. Remember I said that? If there are 52 weeks in a year, and there are 2 weeks a fortnight, then there are 26 fortnights in a year. Huh? So when you get the fortnightly rent, you multiply that by 26 to get the annual rent. Right? That is the fortnight, 26 fortnights in a year. So we take the fortnight rent to this, I multiply by 26. Let's do the calculation because we have the 12 something. So 647 times 26, that's 16,822 divided by 12 months. Oh, that's the amount for rent per month. All right. Next part says, all of Irma's savings is used to pay her son's university tuition, which is $150,000. That's the total tuition, $150,000. If Irma pay remains the same, and she saves the same amount each month, so we have to work out the amount she must save per month as well. Again, she saves the same amount each month. What is the minimum number of years? Okay. If she saves the same amount each month, she's gonna end up saving the same amount per year as well. All right? So we can work in years. So what is the minimum number of years that she must work in order to save enough money to cover the son's tuition? So what we need to find out is how much she save per year. And I'm going to divide this now, the total of 150 by the amount that she saves per year, because she's saving up to pay the tuition. So we need to find out how much she saves per year. So let's look at the saving figure per fortnight. Remember, this is a fortnight figure. So this is the savings right here. So 1750 is the savings. So the savings per fortnight is 1750. I'll give you all the details. So savings per fortnight is 1750. Savings per fortnight equals 1750. Therefore, savings per year equals 26 times 1750. And then we work that out. 26 times 1750 on the calculator is giving me 45,500. That's how much she saves per year. You want to know how many years it will take saving this amount per year? How many years it will take to reach that 150,000? Right? So the number of years to reach 150,000 payment equal the 150,000 divided by the amount she saves per year. 150,000 divided by the 45,500. And you work that out. So it's 150,000 divided by 45,500. Put as a fraction. See there? That's the calculation up here. All right? And that gives us 3.3. So she have to work more than 3 years. So because I said number of years, the minimum number of years you have to work, you have to put 4 years. She have to work more than 3 years, it is 4 years. When a question asks you for the number of something, what did I do there? Let's do it. 1500. I did something with the calculator and I pressed something wrong a while ago. I don't know what I pressed. I pressed something wrong a while ago with the calculator. I changed the function on it apart. Oh man, I don't know what I did. Something on it a while ago. I changed the function of the calculator. I don't know. I don't know what I did. Change it to a logic calculator. Wow. Hey, I don't know how to get it back. I did something wrong. It's gone. Oh, it's gone to binary. Oh, it's in decimal. Okay. It's gone to binary. It went to binary. That's what 150,000 divided by 45,500. 3.2. So you're getting 3.29, call it 3.3. 3.3 years. That's for the number of something, guys. You have the number of something is a counting thing. So ask it, look at it. It said the number of years she has to work. You have to put 4 years. You have to work more than 3 years. So she's have to work 4 years. Understand? So this is 3.3 years, meaning she can pass 3 years. So she has to work for 4 years. That's the answer right here. Don't put 3.3. She has to work for 4 years. And the question asks for the number of years. Once a question asks for the number of something is counting. So she has to work for 4 years. All right? That is it. All right. It's a shot. All right, guys. Question one, though. I think I spent too much time. This question says, simplify this thing completely. So it's a multiplication of indices. When you multiply indices, you add the powers, right? You know that, right? It becomes 3 times 4 is 12. And the p squared and the p to the 5th power becomes p to the 2 plus 5. 2 plus 5 is 7. So you get 12 times p to the 7th power. You multiply indices in the same base, you add the powers. So it becomes 12 times p to the 7th power. Simple as that. Next one. This one, when you divide a fraction, you invert and multiply. Good? We all know that, right? When you divide by a fraction, you invert and multiply. Oh, man. All right. So this then becomes equal to, I'm going to write about this fraction first, which is 3x over 4y cubed. I'm going to multiply the inverse of this, flip it. So I'm going to put a 20y squared on top and the 21x squared on the bottom. They will just cancel now. We'll just start to cancel values. So let's focus on the numbers first. So 3 into 3, this goes 1 time. 3 into this 27, 21 goes 7 times. 4 into this goes 1 time. 4 into the 20 goes 5 times. 5. Then we have the x values now. X into this goes 1 time. X into X squared, leave me with just X. I can cross this 2 and put 1. Then the Y now. We have Y squared and we have Y here. So we can cancel the Y squared out of this and we'll cancel 2 out of this. We're left with 1. 1. Understand that? Good. And then just multiply the rest of the values now. So this numerator works out to be 1. Let's work it out. 1 times Y under here times up here we're going to have just the 5 left up here. And there's a 7x left under here. 7x left under here. 7x. And then multiply them out. 5 times 1 on the numerator is 5. And 7xy, that becomes 7xy. 7xy. Numerator becomes, denominator becomes 7xy. That is the answer right here. Just be careful and progressively cancel it out. All right? That is it. Let's continue. Question wants us to solve this. Solve means find the unknown. So we're trying to find the x out of this. This can be done in multiple ways. I'm going to use a method first because this is 0. I'm going to use a method of taking this over this side and then cross multiply to expand it out into separate terms. So I'm going to write this first as 3 over 7x minus 1 equals, take this over this side and it becomes minus 1 over x. When I get that now, I can cross multiply. I multiply this up here and multiply that up there. Cross multiply. When I multiply the x up here, I'm going to get 3x. When I multiply the 7 minus x1 over there, I'm going to get the minus 1 times the 7x is minus 7x. And the minus 1 times the minus 1 becomes a positive 1. I'm going to take this 7x and bring it over here and add it to that 3x and get 10x equals this 1 that remains here. Then divide by this 10, we get x equals 1 over 10. That is the answer. What good? Let's do it another way. More maths equals better maths. Or I could decide to write this and make it into 1 fraction. Add it and make it into 1 fraction first. And leave it equal 0. So I could make it into 1 fraction first. Or would I make it into 1 fraction? Let me write it over again. So 3 over 7x minus 1 plus 1 over x equals 0. To make it into 1 fraction, I want the 2 denominators to become the same. Or the 2 denominators to become the same. For the 2 denominators to become the same, I need to multiply this denominator up here and down here. And multiply this denominator up here and down here. So it's like I'm multiplying this fraction by x over x. So I have, write it back. I'm going to multiply beside it. Let me just do it beside it. This small, I'm going to do beside it. Right. So I'm going to multiply this fraction, numerator and denominator by this denominator, which is x over x. Multiply this fraction by x over x. Multiply this fraction by this denominator, numerator and denominator by this denominator. So I'm multiplying it by 7x minus 1 over 7x minus 1. And that's all equal to 0 still. So what happens now? This numerator becomes 3x over x times 7x minus 1. X times 7x minus 1. Plus, this denominator becomes 1 times all of this is just 7x minus 1. 7x minus 1 over the same thing. X times 7 minus x. X times 7x, no, 7x minus 1 equals 0. One of the 2 denominators are the same. We can consolidate, add the values on the numerator and put them over the common denominator. So the 3x plus 7x is 10x. So it's 10x minus 1 over the common denominator x into 7x minus 1 equals 0. Then the way right here, so now. If a fraction equals 0, it is the numerator that has to be equal to the 0. If a fraction equals 0, then it is the numerator that has to be equal to 0. I can look at it this way. A transposition I can do is to take this denominator, multiply it across here by 0. So 0 times this thing is going to give you back 0 anyway, because 0 times anything is 0. So anyway you want to look at it, you're going to end up with this denominator equals, this numerator equals 0. So you're going to get, therefore, 10x minus 1 is equal to the 0. If 10x minus 1 is equal to 0, pure over the 1 and get 1 and then divide under the 10. So you get the same answer, x equals 1 over 10. Same answer. So I don't know, maybe this method over here is that. That's algebra. But all right? Good. And there are other ways to do it as well. This is not the only 2 ways to do it. Huh? But that is it. Huh? You sure? But, huh? Because I take this and carry it over becomes a negative number. Becomes negative. If I take this and carry it over the right side, it becomes negative. I just write it as negative 1 over x. Spoon. All right. Now cross multiply. All right. X1 number, this one. This one says, when a number x is multiplied by 2, the result is squared. Let's go again. When a number x is multiplied by 2, the result is squared to give a new number y. Express y in terms of x. So a number x is multiplied by 2, that gives you 2x. And the result is squared to be equal to a number y. That is it. But that's not. So they say make y in terms of x. In other words, you must put y up on the left side. So that is y is equal to, if you square this, now you're going to get 4x squared. Y is equal to 4x squared. You square this thing. Square the 2, you get 4. Sorry. I square it to get x squared. That's it. So when the number x is multiplied by 2, that's how I get 2x in here. And that 2x is now squared to give, meaning equal, a new number y. That's what they said. All right? And this works out now to this right here. And let's continue. He said, determine the two values of x which satisfy the equation y equals x and the equation above. Remember, the equation above is this. The equation above is y. So basically solving, that is, i.e., we are solving y equals x and y equals 4x squared. Yeah? So y equals x, and the equation above is y equals 4x squared. So if you solve these two equations simultaneously, instead of one to another, determine the two values of x that satisfy these two equations. And the only one of the values of x, it makes sense to eliminate the y. So if y equals this and y equals that, it means that these two things now equal. So you can say, therefore, 4x squared will be equal to the x. The important thing here, guys, don't divide out the x. Don't cancel the x, because you'll be eliminating a value that you're trying to find. What you have to do is cure over this x over here and factorize it. So you get 4x squared minus x equals 0. Then you factorize it. Factorize on the x, you're going to get 4x minus 1 equals 0. See? So you get the two values of x now. Either the x equals 0, because remember, the product of two numbers equals 0. Either this one equals 0 or this one equals 0. One of them is 0, one of the other is 0. So either this x equals 0, it's going to give you one of the values of x. Either x equals 0, or if this equals 0, you're going to get x equals 1 over 4. But can you see the 1 over 4? But I see it? I am going to write the next line. Let's write the next line. So it's x equals 0 or 4x minus 1 equals 0. If 4x minus 1 equals 0, then the x equals 1 over 4. So these are the two answers, two values of x. That's an answer right here. And that's the other answer right here. Two values of x. You don't want the y value, you just want the x values. Very good. The y value is actually going to be 0. I plug 0 right here, well, actually 0. Plug 0 right here, and you're going to get 0 or a quarter. It's going to be 0 or a quarter. Yeah, 0 quarter. But anyway, they don't want the y value, just the x values. Let's go. Number 3. So number 3 wants us to do this construction. What did I say? Sketch it before you construct it, right? It says using a ruler, a pencil, and a pair of compasses, construct triangle NLM in which LM is 12. Sketch it before constructing. So the LM is 12 centimeters. That's the L. The angle at L, see the angle at the middle value there, the middle letter there is the L. So the angle at L is 30 degrees. So right here you need a 30 degrees angle. And the angle at M is 90 degrees. See, at M over here is 90 degrees. So right here you need a 90-degree angle. So that's why you're constructing 90 degrees. So you're constructing that. So remember, to get the 30 degrees, you're going to construct a 60-degree arc and then bisect it, right? Construct a 90 degrees, you're going to construct a 60 and a 60, bisect the second 60. That's the method. Let me get the thing I'm constructing now. Let me get the thing and construct it right here. What's that? Why are you doing that? Yeah, I'm just doing it. All right, so we're going to construct this thing. N is up here. All right, constructing that triangle. All right, so we're going to draw the 12 centimeter line first with the ruler. Bring in the ruler, we need a 12 centimeter line first. So 12 centimeters all the way out to 12. So we're going to construct use a compass. And we're going to construct a 30 degrees angle here. To construct a 30, remember, we are going to construct a 60-degree arc and then bisect it. Only two arcs make two arcs across each other makes a 60-degree arc. So I'm going to mark this one first. And move the point to here. Rotate up here and cross that one. I don't need to put in the 60-degree line. I don't need to put in the 60-degree line. It's 30 degrees I want. So I'm going to bisect this arc now. This arc right here, I'm going to bisect it. So I come to this end of the arc. Rotate around here. I want to bisect that arc. Put the line over there, the arc there. Come back up to this end of the 60-degree arc. Rotate down. Cross that one. So the line through there is going to be 30 degrees. So I'm not going to draw it yet. I'm going to put the 90 degrees over here now for this end. So let's construct a 90 degree over here now. Let me do that one in blue. So to construct the 90 degrees, remember, we're going to construct a 120 arc first, a big long arc. 120, more than 120, all the way over here. We're going to come to this end. I'm going to cross this one first. That's 60. They'll come up to here and cross that second one. And that's now a 60 and a 60. I need to bisect the second 60 up here. This one up here. I need to bisect it. So come to this end of the arc, rotate, and draw my line over there, my arc over there. Then I come down to this point and rotate and cross that one. All right. Then I'm going to draw my 90-degree line first. I didn't do it at the end, though. Because I didn't do it at the end of the line. I did not start at the end of the line down here, so I have to do it over. I have to do it over. I have to get the end of the line. So let's go again. Need a 120-degree arc first. Come to this end. Cross that one. That's 60. Come to this intersection. Cross this one. That's the second 60. Then if you bisect angle up here now, 60 arc up here. Come to this end. Rotate over. Make an arc up there. Come over this end of the 60. Arc. And cross that one. Good. Now the straight line to the intersection. That's going to be 90. And then the straight line through this section, extend it out. I need to extend that first line up some more. So I'm not bother with this one yet. Let's go back for the first one. Draw it further out. Through the intersection, that maybe up to here. It's 90 degrees. And then through this intersection is 60 degrees. I'm going to extend it all the way out. And so if I label it up now, right here is L, right here is M, and this intersection is N. Angle is 30 degrees. This angle is 90 degrees. And this is 12 centimeters. 12. That is it. I'm going to copy this thing. I'm going to copy this thing. And put it on the screen, put it on the page. All right. That is the construction right there. That is it. Sketch it and then construct it, guys. That's a construction. All right, good. What else I want to say? That's all. That's a construct. They will come. Huh? Yes? So this is actually these right here. All right. Come back over to here now. That's a transformation. It says triangle ABC has coordinates. Vertex is 1, 1. That's good. B is 1, 4. C is 3, 1. You can see them on the diagram, right? That's a diagram. What do they want us to do? It says Triangle ABC is mapped onto LMN by reflection in the x-axis, followed by a reflection in the y-axis. On the diagram, draw LMN. So because I change up the letters, normally we'll give it A prime, B prime, C prime. I'm going to make sure that my letters match. Just make sure. So basically, based on this, it is A going to L, so the first letter to the first letter. Then B going to M, second letter, M. And it's C going to N. Just make sure. So they reflect in the y-axis, and they reflect in the x-axis, and they reflect in the y-axis. You should know that that's a 180-degree rotation. A reflection on the y-axis and a reflection on the x-axis combined to be a 180-degree rotation or a reflection to the origin. What you have to do them say? They want to reflect in the x-axis and they reflect in the y-axis. So let's do them one at a time. So reflecting in these two lines. X-axis is one mirror line, and then y-axis is the other mirror line. Reflecting in those two lines. Let's use the blue. So this point, we reflect over the x-axis is coming down to here first. The reflect over the y-axis is coming to here. So this point is coming to here. What can I do with that? So this point is going to be L. L. All right, so come down here first and then go across here. Then B now. B reflect B in the x-axis is 1, 2, 3, 4 to the mirror line. It's going to go 4 on the other side. 1, 2, 3, 4. So B is coming to here first. So the B is coming all the way down to here first. I want it over here. So it's 1, 2, 3, 4. It's going to go down to -4 reflective of the x-axis. So it's going to come all the way down to here, the B. So the B is coming down to here first. And the reflective of the y-axis is going to go 1 unit across, right? 1 unit across here. So the B is coming to this point. And as we said, B went to M. So this point becomes M. Then the C now. The C, let me use a different color for the C. It's purple. So reflect the C in the x-axis first, it's coming down to here. The reflect over the y-axis now is 3 units going to go 3 units on the other side. So it's going to come 3 units on the other side. So it's coming to here and go 3 units, 1, 2, 3 over to here. So it's coming over to here. The C is coming over to here. All right? This distance and this distance is the C. So C is going to that point. And C goes to N. So this point becomes N. And then draw the triangle through these 3 points. All right, let's draw a triangle through these 3 points now. Mm-hmm. Huh? Do it again. All right. I'm going to do it in one movement, right? I'll show you in one move. So A first. Let's say reflect over the x-axis and then reflect over the y-axis. But image distance equals object distance, right? So reflect this point over the x-axis. It's going to come to here first, right here. And reflect over the y-axis, now it's going to come to here, right there. Make sense? Huh? All right. When you reflect over the x-axis, it come to here first. I need to reflect this over the y-axis now. So go to the y-axis here. So the distance from the mirror, you're going to go to there, so to there. But image distance equals object distance. Good. I would do the same thing with all the points. For this one, it is 1 to the mirror line, 1 to the other side to your first over the x-axis. And it's 3 units to the mirror line. So we're going to 3 on the other side to here. So this point is going all the way over to here. See that? And then the B is 4 to the mirror line, and then you got 4 on the other side. Then this is up to 1 to this, 1 over to here. So the B is coming all the way down to here. So, all right, let me see if we can get back to this marking that I had before. I delete it. I want to understand it. That's it, right? So that is your LMN. The diagram. This is now your LMN. So this is your LMN. All right. Then it says, no, draw the element. That is it. We have drawn it. Good. We have drawn it. Reflect over the x-axis and then reflect over the y-axis. So it's in 2 books. Same as doing the reflection to the origin. Look, the reflection to the origin, you know, look. This point, you come to the origin, you come straight to here. So see there? At this point now. C, you come to the origin, you come straight to there. So I want it to give rotation. Look at the next one. B. Come through the origin, come straight down to there. So see that? So remember, we did a reflection over the x-axis, we did a reflection over the y-axis. 2 reflections over intersecting lines is equivalent to a rotation. Since the angle between these 2 mirror lines is 90 degrees, the angle between the x-axis and the y-axis is 90 degrees, then it is equivalent to a 180-degree rotation about the point of intersection of the 2 lines, which is the origin. So it's like you take that point here and rotate it 180 degrees over to there. So that is it. And like you take this other point, the A, and you rotate it about this point again, 180 degrees to there. So see there? And it's like you take this point up here and rotate about the origin 180 degrees down to here. So see there? Or same as reflecting through the origin. But it's good information to know, guys. 2 reflections equivalent to the rotation. The angle of the rotation is twice angle between the 2 lines. They want us to do anything else. They said, describe a single transformation which maps ABC. See? You have to know that from ABC to LMN is a 180-degree rotation about the origin. Right? See, there are 180 degrees rotation about, how they put the direction clockwise. Things will go down and up. 180 degrees clockwise rotation. 180 degrees clockwise rotation about the origin. That's why I told you need to know that 2 reflections are equivalent to a rotation and the lines intersect. That's what we have. Stay the 2 by 2 matrix which maps ABC and to element. Again, you have to know the rotation matrix. The 180-degree rotation matrix. It is -1, 0. The y-axis reflection in it, and it has the x-axis reflection in it. There's another example of a question that tests your knowledge of the matrices. This is the matrix for a 180-degree rotation about the origin. -1, 0, 0, -1. So you see, that's why I tell you need to learn. Know that. One get good, one get exam, know what you need to know. All right? That's the matrix for that. But people want to waste time, figure this out, to get the 1 mark. It don't make no sense. You cannot know it and write down the answer about the business. Know what you need to know, guys. You need to know. I tell you the thing that you need to know. This one says, P varies inversely as the square of V. Note that the square of V means V squared. And it's inversely means K over. It says using P, V, and K, form an equation connecting the P and the V. So the P, the first variable, because it's inverse, is K divided by the second variable, which is V squared. That is it. Inverse variation. You have P and you have V squared. The square of V is V squared. So P varies inversely. Inversely means K divided by. All right? That's a relationship. Then again, this question is saying, given that V equals 3 when P equals 4, determine the V when P equals 1. Again, this question not asking for the K. We can work this out without finding the K. If you make K the subject of this, by multiplying up the V squared, you'll see that the K is equal to P times V squared. So the P times V squared is a constant. We can use that. The P times V squared is a constant. So P times V squared is equal to the same thing all the time. So we're going to use that. The constant is P times V squared. P times V squared is a constant value all the time. So you do have to calculate the thing here. So it means that this P times this V squared is equal to this P times this V squared. Because P times V squared is the same value all the time. Constant. That's what we use it. All right? So, as I said, this P times this V squared is equal to this P times this V squared. That's what we're going to say. P times V squared is a constant for any pair of bodies. So, this P, let's call this P1 and P2 and V1 and V2. So that P times V squared for one pair of value equals P times V squared, the second pair of value. This is one pair of value, that's a second pair of value. So kind of setting it up for you. So the P times V squared over here, so is 1 times V squared. And that becomes equal to this second pair of value now, the P is 4. So it's 4 times, and a V here is 3. 3 squared. Understand that? Because the P times V squared for any period is the same all the time. So now you can work out this V. But this works out to be what? This means that the V over here so becomes the square root of 4 times 3 squared. Which becomes 2 times 3, 6. Because this under here says it's really 36. Square root of 36 is 6, so the V equals 6. And this works out to be V squared. V squared equals, write that second line for you. Write that line for you. Shift this up. So this becomes V squared. This becomes 36. So Vn is the square root of 36, which is equal to 6. That is the answer. V equals 6. So over here, so the V is going to be 6 when the P is 1. All right? P times V squared is the same value for any pair, for all the pairs. Youngster, give me that phone number. And talk to your parents. I can't just something with you. Thanks. I'll be at the chat. Next question. Given that X is a real number, solve this inequality. Solve this inequality, you have to transpose everything away from this X. Leave X alone in the So we have to do. Transpose everything away from that x. First we want to move is this 5. That's a plus 5. So we're going to subtract 5 from all the sides, from all 3 sides. This has 3 sides. One over here, one in the middle, and one on the right. Right? So we're going to subtract 5 from all sides first. Minus 5 from all sides. When minus 5 from this side, it becomes negative 12. Less than when minus 5 from the middle, the 5 gone, you have 3x. Less than or equal to, that's less than or equal to. When you subtract 5 from this side, you get 2. But that's not so far. Let us leave x in the middle. We need to get rid of this 3 to get rid of that 3 of divide through by a 3. So we'll divide all the sides by 3 now. Divide through by 3. So we divide this by 3, it becomes negative 4, less than. Divide 3 by 3, it becomes x. Less than or equal to divide 2 by 3 becomes 2 over 3. That's the answer. All right? That's the answer, right? We leave x in the middle. And so you solve it. And find even x alone in the middle. That's it. I remember for inequality, to multiply and divide by a negative number, you have to reverse those signs, but you multiply by a positive number, so the signs stay as they are. Next part now says, represent your answer on a number line. So basically, your answer is that x is between negative 4 and 2/3, not including the negative 4, because there's no equal there. So you put the unshaded circle on the negative 4. Then on the 2/3, I will put a shaded circle because the equal is there on that end. We want to reach between negative 4 and 2/3. Let's go. We'll put on this number line. So let's say this is 1. Let's say this is negative 1, negative 2, negative 3, negative 4. So right here would be about 2/3. If this is 1, divide to 3 equal parts, then right here is about 2/3. So you put in a circle on here, because the equal is on that end. You have to shade that circle. Shade it. At the other end is negative 4. So you're going to put a circle on the 4. But this time, leave the circle unshaded, but not included the 4. Then you just join these. That is it. To the right of that, to the left of that, and to the right of that. That's it. X is less than or equal to 2/3. That's why I have the shaded circle on the 2/3. But it is only greater than negative 4. That's why on the negative 4, the circle is unshaded. That will be, it's got to be your number. Very good? All right. Next question. They give us this equation of a line. All right? And they said the line cross the y-axis at Q, in the coordinates of Q. Well, Q is going to be 0C, 0C, because the y-axis intersect. So if you can find the C, we're good to go. Or find the C. By putting this equation in the form y got mx plus c, don't it? Make y the subject. Put it in the form y got mx plus c. And you will know what the C is. And don't you ask for the gradient. You'll also know what the gradient is. If you can get this in the form y equals mx plus c, get this equation in the form y equals mx plus c. That's right. Get y equals mx plus c. Get it in that form. Get y alone as a subject. So we're going to take this equation and do that, right? So this equation becomes first. Carry over the x over 3 first. You're gonna get y over 7 equals minus x over 3 plus 1. Then to get rid of this 7, you're gonna multiply by 7. Multiply by 7, multiply this by 7, multiply that by 7 as well. So I'm gonna multiply by 7, put out here, multiply by 7 to get rid of this 7. So I'm gonna get this. Y equals, this is minus 1 over 3, that's what that is. So I'm going to get minus 7 over 3 times this x. I put x to the side of it. Multiply this by 7, you get 7. So this is the M, this is the C. See there? So based on this, you can make a note. M equals minus 7/3, and C equals 7. So the one the point Q. So you can write it now. Let's put it in purple. Therefore, Q is the point 0, 7. That is it. That's the answer. 1 mark for that. Then you want the gradient. Gradient is M. Gradient is M, which is minus 7/3. Yes, and this. So step the line, put it in the form y equals mx plus c, and you are good to go. Take this line and write it in that form. You're good to go. That's why I said get y equals mx plus c. That's what I mean by get it in the form y equals mx plus c. That's what O is ready for that. All right. Put the form y equals mx plus c. You can see what the gradient is, and you can see what the y-axis is. So because time becomes very easy. All right, done. That is it. But all right, I'll be able to transpose, guys. I'll be able to transpose. All right, let's continue. Number 5, statistics. A cumulative frequency curve. No, this is a cumulative frequency curve. When CSEC set this exam that year, a lot of people missed that was cumulative frequency. Why? Because we are so familiar with just getting frequency. But in this question, they gave you the cumulative frequency. So if I'm doing a question where they give me the cumulative frequency, my first action before we start doing anything is to work out the frequency values from it. Because the frequency values are the values on each line. You want to know what the values are on each line. What it says, the cumulative frequency distribution of the volume of petrol needed to fill a tank of 150 different vehicles is shown below, was a cumulative frequency. See? That's why it ends at 150. I'm going to put in a column for the frequency. And I'm going to put it over here. I'm going to put it here. With column for the frequency. Let me put it right here because frequency normally comes before cumulative frequency. So I'm going to put it right here. Put it in red, frequency. Put F for frequency. Don't mind that this come over here. I'm going to put a frequency right here, F. Put in a frequency column. Now, if you add it to get cumulative frequency, they have to subtract to get frequency. You understand? Make sense? If you add the frequency to get cumulative frequency, they have to subtract the cumulative frequency to get the frequency values, right? And the first one is always the same. That's 24. Then to get the value here, remember, you'd have added this 24 to something, 59. So to get the value here, you're going to do 59 minus 24. See that? 59 minus 24. What is your record? We'll put this in blue. I'll leave it in red, don't matter. So 59 minus 24 is how much? 25 that? Huh? 35. Then after do, you get the value here, get this value would have been 59 plus this, give me that. So to get the value here, I'm going to subtract 101 minus 59. How much is that? How much? 101 minus 59 is how much? 42. And same thing here, it's going to be 129 minus 1. What is that? How much? It's going to be 150 minus 129. How much is that? How much is that? 21. And then to make sure you can add up these values, I must get 150. Check it for me. Add them up and get 150. You must get 150 where you add them. Get 150? All right, so this equals 150. So you know, so you get the right values, right? So what this means that there were 24 in this group. There were 35 vehicles in this group. There were 42 vehicles in this group. There were 28 vehicles in this group. And there were 21 vehicles in that group. I'm ready to answer questions now because I've armed myself with more information. Question says, for the class 21 to 30, which is this one, 21 to 30. What is the lower boundary? What's the lower boundary? It is the 0.5 less than this, don't it? So it is 20.5. I have to put liters. Put unit of measure. It's a lower boundary. Remember, this class, it goes from 20.5 up to 30.5. Remember, it goes from boundary value to boundary value. So this class goes from 20.5 up to 30.5. Now they can put equal on this end, or they can put equal on this end. Whichever end they put it on, they have to stay consistent throughout. I'm going to assume that it is on this end. All right? Let's continue. Class width. I can know what the class width is by looking at all these values increase. The upper limit increasing by 10, the lower limit increasing by 10. So the class width is 10. But you can also calculate the class width by doing upper boundary minus lower boundary. See that? Still going to get 10. So the class calculation will be 30.5 minus 30.5, which is equal to 10 liters. Make sure you put on the unit of measure of the data. The data is a liter. What good so far? 10 liters. Next question. How many vehicles were recorded in the 31 class? That's a frequency. 31 to 40 is 42 vehicles, don't it? 42 vehicles. See that? What is that? See there? Work out 42 vehicles in this class. 42 vehicles. That's what's right. 42 vehicles. Don't need no calculation. I've already worked out in the table. So the frequency value we're looking for. The number of vehicles, the frequency. 42 vehicles. Next one. A vehicle is chosen at random from the 150 vehicles. It said, what is the probability that the volume of petrol needed to fill the tank is more than, more than. That means greater than 50.5 liters. That's what greater than me, more than me. So I want to know how many vehicles had a petrol, had amount of petrol greater than 50.5. Let's look at it. It's these they're talking about. You know? See that? Those were greater than 50.5. Say 50.5 stop in another group or so. This group was 40.5 up to 50.5. So this group stop at 50.5. So these are the ones that were more than 50.5. So these are the ones that were greater than 50.5. Or I can put it this way. This group starts from 50.5 and it ends at 60.5. So you see, more than 50.5. So that's the number of vehicles in that group, 21, right? 21 vehicles. So the probability then down here becomes equal to, let's write it out this way. Probability of being greater than 50.5 liters, of getting greater than 50.5 liters is 21 vehicles over the 150. 21 over 150. 21 over 150 is 7 over 50. 7 over 50. 7 over 50 vehicles. That is the answer. Very good. I don't need this again. So. All right. Next part says, Byron estimates that the median amount of petrol is 43.5 kilograms. Explain why Byron's estimate is incorrect. So to explain why estimate is incorrect, you must see which group the median really supposed to be in. All right? So what we're gonna do? So if there are 150 vehicles, the median amount is amount obtained by which vehicle approximately? If there are 150 vehicles total. The median amount is the amount obtained by which one of the vehicles? One in the middle, 75 for one. Good? So the median corresponds to the amount taken by the 75th vehicle, don't it? One in the middle. If there are 150 vehicles, the median corresponds to the 75th vehicle. So the median is the amount taken by the 75th vehicle. But the vehicles are in ascending order in terms of the amount that they're taking. 75th vehicle. We go up on the table now and say where the 75th vehicle will be. So the cumulative frequency, adding up the vehicles. So the 59 vehicle done another group here. So the group here end at the 101 vehicle, this group. So the 75th vehicle is in this group, don't it? So that the 75th vehicle is in that group. 75th vehicle is here. Right? 75th vehicle is there. So the 75th vehicle is a vehicle where take one of those measurements. Right? And the figure I gave us 43 point something, that'll be one of these measurements. It is wrong. See that? So that's what you're going to say that it is wrong. The 75th vehicle is in the 31 to 40 group interval, class interval. So you're going to write it. So the median amount is amount taken by the 75th vehicle. The 75th vehicle is in the, go again, 40 to what? 31 to 40. Is in the 31 to 40. Is in the 31 to 40 liters class interval. And then this amount is not in that class interval. Right? 43.5 liters is not in the 31 to 40 liters interval. And is therefore not the median. The median is a value that a range at a so. That's what the 75th peak is it. The median has to be a value inside this range of values. You get me? Has to be a value between. And that is actually from 30.5 up to 40.5. So anything outside of that, not the median. Because the median corresponds to the amount of petrol taken by the 75th vehicle. But that's not that reasoning. How to go to that? All right. All right. Next thing, what do I want us to do? They say now, on the partially labeled grid below, construct a histogram. Remember that the bars of the histogram go from boundary value to boundary value. Right? Construct a histogram to represent the volume of petrol needed to fill the tank of 150 vehicles. All right, so we're going to put on this scale, right? So down here, we're going to put the volume of petrol. We're going to put the volume down here in liters. I'm going to put on with the bars of histogram. We're going to have to scale this up first. So let's see what they go up to again. It goes up to, the volume goes up to 60. And it starts at 10. So we're going to see if we go by 10, we go up to 60. Let's go. So let's say we go 10, 20, 30, 40, 50, 60, good. 10, 20, 30, 40, 50, 60. But be careful now, because the bars of the histogram, they go on the boundary values. They go on the boundary values. They don't go on the limit values. They go on the boundary values. And the boundary values are 10 apart, CMA, because the class it was 10. What are the boundary values? The star mark them. So the boundary value for this end start at 10.5. Zoom up. So that's the 0.5 marks. That's it. Start at 10.5 up to 20.5. That's this class interval right here. All right? So it's 10.5, 20.5, 30.5, 40.5, 50.5, 60.5. So those are where you're going to put the bars and the boundary values. First bar is at 10.5, the last bar is at 60.5. They are 10.5 apart. If I put in this one is going to be 30.5 up to 40.5. So the bars of this diagram go from this boundary up to this boundary, and they are 10 apart. So it's 10.5, 20.5, 30.5. Those are where you put the bars. The first bar is good. Histogram will have these frequency values. Histogram, you're going on the frequency values, not the boundary values, the frequency values. All right? So the bars go from boundary value to boundary value, and the height of the bar is the frequency. Height of the bar is the frequency. So let me copy this down. Copy this down so we can have a picture to look at. Let's spin it. All right. So I use that to draw the graph. So those are the values here. I see them up here. They're small. All right. So I'm going to put on where the bars going first and the 0.5 marks. So watch this now. This is 10. That's 11, 12, 13, 14, 15. So the 0.5s are like right in between here. So at 10.5, that's 20.5, 30.5. This is 40.5. This is 50.5. And that is 60.5. The bars are going to go on those red marks. So the first bar going up to 24. See there, 24. First bar going up to 24. So the first bar going up to 24. Where's 24? 20, 21, 22, 23, 24 is this line. First bar going up to 24, which is right up here. That's where the first bar going up to. So the first bar, you know. That's the first bar. All right? The next bar going up to, the next bar is going up to 35. See it on the table there, 35. Next bar going up to 35. So up to 35 is right on this line. And this bar continues up to there. And this bar goes up to there as well. Up to 35. The next bar is up to 42. Next bar goes up to 42. So where's 42? 42 is up on this line here, so 42 is on this line. So 42 is up here. So next bar coming up to there. And this bar goes all the way up to there as well. Right? That's it. 42. The next bar drops down to 28. So we're in 28 and then 21. The last two bars, 28 and then 20. So it's 28. 28 is right on this line here, so 28. That's a 28 line. So coming across here, and the bar drops down to 28. So coming down to here. And the last bar drops down to 21. 21 is right here. This is 21. That's 21 line. That line is 21. So we're coming down to here, 21. I finish that one down. That's it. That's the histogram. And notice the bars of the histogram, they are on the boundary values. We go from boundary value to boundary value. See it? Very good. Very important. They have to go on from boundary. If you don't put them on the boundary value, don't let them place them. You're gonna lose marks. And they join each other side by side. Very important they put them on the right place. Bars of the histogram go from boundary value to boundary value. From 10.5 up to 60.5. And then the height of the bars is a frequency. The cumulative frequency, the frequency of the histogram measure. That is it. That's histogram. I think that finishes that question. Number 6. Let's see if we can speed up a little bit. It's starting already. Question says, scale of a map is 1 to 25,000. That means 1 centimeter on a map is 25,000 centimeters on land. Determine the actual distance in kilometers for 0.5 centimeters on the map. So I want to get the distance scale first from this information. All right, so let's look at it. So this scale means that 1 centimeter, or let's put map to land. Map to land, and this is scale for distance. That's right. So this is scale for distance. Distance. It's one map to land. Map to land, Mr. Shaw. Map to land. Map to land. It's 1 centimeter on the map, 25,000 centimeter on land. 25,000 centimeters on land. What convert this side to kilometers? Divide by 100, you get meters first. So it's 1 centimeter on the map. Divide by 100, you get 250 meters. 250 meters on land. Then to get kilometers divided by 1,000, so it's 1 centimeter to divided by 1,000. 1, 2, 3 is 0.25 kilometers on land. They want 0.5 centimeters. To get 0.5, multiply by 0.5. Because they want this side to become 0.5. So it means then that 1 centimeter on the map, this times 0.5 is 0.125 kilometers. This right here is your answer. This is the answer. This is the answer right here. Not 1, 0.5. Not 1, 0.5. 0.5 centimeters on the map is that. Why did I do this? I want to write the distance, the area scale. The question asks us for area. So I'm just going to do the area scale right here. So the area scale. So see it right here. So area. I'm going to do on the next page still. That's the scale for area, for distance. Shift this over. Now this question is asking us for area and kilometers, right? So we'll start back with this distance scale and get the area scale. We're gonna square it. We're gonna square the distance scale to get the area scale. Square it to get the area scale. So this is the distance scale. I'm gonna square that to get the area scale. Map again to land. Put this arrow further down. So squaring this to get that. So when you square this side, one square, square 1 centimeter, you're gonna get 1 centimeter squared. So and you square this value now, right? So you're gonna get 0.25 squared kilometers squared. When you square it. So you're gonna get 1 centimeter squared. 0.25 squared is how much? 0.25 times 0.25 is 0.06. Again, 0.0625 kilometers squared. That's scale. But area. Question said no. Calculate the actual area for 2.25 centimeters squared on the map. So we're gonna get it to come 2.25 simple. Just multiply this now by 2.25. So this time become the 2.25 that they want it to be. So they're gonna get 2.25 centimeters squared on the map. It's now equal to multiply this number by the same 2.25. So it's 2.25 times 0.0625. I'm getting 0.140625 kilometers squared. Let's give them an exact one. But that's not that. That is it. So remember, to go from distance scale to area scale, you square the distance scale. Square it. To get from distance scale to area scale, you square the distance scale. Square the distance scale. So this is the scale for distance. I will square it to get the area scale. Right? You square it to get the area scale. That's all I have to do. Next question. So measurement question. It said diagram below shows it's not drawn to scale, it shows the cross section of two cylindrical jaw. That's really the cross section. Cross section is supposed to be the circular end there, so don't worry about it. Jaw X and jaw Y. The diameter of jaw X and jaw Y are 3D and D centimeters respectively. We're gonna work in radius. I'm gonna put radius on there. Let's call this one jaw radius X. So radius X is 3D over 2. Let's call it radius Y. For this one, radius Y is D over 2. Tend to work in radius. So let's just do that. You work in diameter too, but tend to work in radius. D over 2. We divide the diameter by 2 to get the radius, right? The radius X and radius Y. They give us diameter, we're working with radius. So let's make a note of it. All right. Now the height of this is 4 centimeters. You can see. That's the depth of water. Water in them. Water, yes. The depth is 4 centimeters. All right. He said, in terms of pi and d, mean pi and d must be in the answer. Volume of water in jar X. Let's do it over here. Volume of a cylinder in jar X is pi r squared h. We're talking about the radius of jar X. And the height is 4. So the radius of jar X, remember, is 3d over 2. And the height in X of water in X is 4. Right? So putting in these values. Change this to red. All right, so putting in those values, and then suppose answer about pi and d. So the volume in jar becomes pi 3d over over 2 squared, and the height is 4. What is that? So the volume in jar X becomes equal to now 2 squared is 4. And that 4 will cancel this 4. And then this 3 squared is 9. And then d squared is d squared. D squared is d squared. This is the answer right here. I don't know what 60, but I do all of this, but that is it. I don't know why they just give numbers to it. But anyway, that is it. The volume of jar in terms of pi and d is this 9 pi d squared. That is it. The first word what I give you. The radius is d over 2, 3d over 2, but the diameter was 3d. And so leave the answer in terms of pi and d. See there, leave your answer in terms of pi and d. So leave pi and d the answer. I want the volume in jar X. So it's pi r squared H, a cylinder. So using the radius of jar X, the water in jar X, which is 4. That's it. So it's 3d over 2 squared times 4. So you cancel this 4, so that's gone. And the 3 squared is 9. This squared, that is, so 9 pi squared. Says all the water in jar X is poured into jar 1. Calculate the height reached. The height reached. So we know that the volume of jar Y is going to be what the volume of jar X was, right? So the volume of jar Y is going to be what the volume of jar X was. So the volume of jar Y is going to be 9 pi d squared. Because we don't get the place I want to go. 9 pi d squared, right? But I want the height reached. Well, let's write an expression for the volume of jar Y now. Let's write an expression for it over here. Now the volume in jar Y is also going to be pi r H in jar Y. So the volume in jar Y is going to be, and we don't trying to find, but the radius in jar Y was d over 2. See there, d over 2. Radius in jar Y is d over 2. Right? Radius in jar Y is d over 2. What we get? D over 2 squared times hy. We're trying to find hy. Right? So this is going to be pi d squared over 4. That is 2 squared is 400 there, so. And the d squared is d squared times this hy. That's what the volume in jar Y is going to be. So this, but the volume in jar Y is also that. So we can equate, right? So we can say, therefore, this thing equals this thing. Pi d squared over 4 times hy is equal to 9 pi d squared. We can start canceling away some things now. So pi on this side, pi on that side. D squared cancels d squared, so I'm left with a 1 up here, sir. Then we need to take this 4 and multiply it over there, sir. So we're gonna get the h in jar Y equals times 4. So the h in jar Y 36 centimeters. Right? So this thing is gonna reach up to a height of 36. Let's draw it. So it's gonna reach a height of 36. So that the liquid is going here. And we're trying to find hy. That's what the question is about. I think it's 40. All right, that is it. I leave this dimension. Sure. Understand that? The volume is the same. All right. There's a lot of algebra to report, but that's the answer. Height in Java is 36 centimeters. Done. Number 7. This is a pattern question, but that's how they give it this year, not a physical pattern, a pattern of numbers. A lot of people cried over this question here, but it's very easy. It says the nth term, Tn, of a sequence is given as this formula. So when n equals 1, that's the first term. When n equals 2, that's the second term. When n equals 3, that's the third term. That's all it means. It says show that the first term is 1. So first term is when n equals 1. So put 1 in this. So T1, first term is 1, becomes 3 times 1 squared, and n equals 1 at T1. So you 3 times 1 squared minus 2. T1 equals 3 minus 2. So T1 equals 1, because it works out to 3 now. So T1 is 1, so that's in sugar. So first term is when n equals 1. That's what first term is. Right, this so first term means n equals 1. Yeah? This paper? No, that's the linear programming. You should be asking me that I should have done the paper. You have to, both papers you have to do. You have to do all the papers that are given on a weekend, not some of them, all of them. You do 1 year, you do the other 1 or 2. No excuse, you need to do all of them, boss. You want to get success in the program, do all the papers that are sent. Next one. What is the third term? The third term is when n equals 3. N equals 3, the third term, right? So that is T3. T3 becomes 3 times 3 cubed, 3 squared, minus 2. That's all? Using this formula. Right? Third term is when n equals 3. That's 27 minus 2. That's 25, don't it? It's 27 minus 2. That's 25. So T3, the third term, T3 is 25. Next part. Given that Tn is 145, calculate the value of n. So you're going to put the formula for Tn is this. 3n squared minus 2. So you're going to write 3n squared 2 equals 145. And they're solving for the n. So I'm going to add this 2 first. You're going to get 3n squared equals 147. When you add the 2, then divide by 3, you're going to get n squared equals 147 over 3, which is what? 147 divided by 3, that's 49. And get n squared equals 49. And if n squared equals 49, then n equals the square root of 49. And don't put a plus on the number of terms. Don't put a minus on it, I mean. So n equals 7. That's the answer. N equals 7. What I go to that? N equals 7. Let's put the formula equals 49 equals 145. Next part. Next part says the first 8 terms of another sequence with nth term, un. That's the expression for the nth term now, un. So u1 means the first term, u2 is the second term, u3 is the third term, and so on. So these are the first 8 terms. See there, u1 is this one right here. So u2 is also 1. That's the second term. u3, so this will be u3. This will be u3. u3 is 2, and so on. So this last one will be u8. That will be u8. u8. So the n is the term number, right? That's what the n stands for, the term number. And this is the formula. When n is greater than or equal to 3, this becomes the formula. What is it? It says the fifth term is the sum of the fourth and the third term. So a term is the sum of the previous 2 terms. So this is the sum of these 2 terms. This is the sum of these 2 terms, 1 plus 2. This is the sum of these 2 terms, 2 plus 3. This is the sum of these 2 terms, 3 plus 5. This is the sum of these 2 terms. What I get a picture? So a term is the sum of the previous two terms. That's what happening here. And you could see that in this pattern. So the question said, write down the next two terms in the sequence. That's U9 and U10. So U9 is going to be some of these two terms, don't it? So that, so U9 is going to be U8 plus U7. U8 is 21 and 13. So it's 21 plus 13. What is that? That's 34, right? 34. And then U10 now. U10 is going to be U9 plus U8. U10 is going to be U9, which is this, plus U8, which is 21. Right? So it's going to be 34 plus 21, which works out to be, that's 55. But understand that? That's 55. It's a little bit, I should say a little bit. That's going to become 55. That's U10. That's U9. U9. All right? U9 and U2. Next question answer. What term is the sum of U19 and U18? U20 that. What's up? U18 plus U19 is equal to U20. That's the 20th term. I cannot write the word 20th term. It's the number 20th term. Say, which term? 20th term. That's the answer. Make sense? That term is the sum of the two terms. Those two must add to give it a 20th term. Okay? That is it. So the 20th term. The answer is the 20th term. Next question. Show that U20 minus U19 is equal to this. Let's work it out. So if we work out this, I must equal that. Let's work it out. So the left-hand side, that's here. This is the left-hand side. It's U20 minus U19. Now the U20 is U20 is U19 plus U18, don't it? That's U20 minus U19 now is U18 plus U17, don't it? That's all. Agreed? If you open up this bracket now, the U18 here subtract the U18 here that gone, right? And the U19 here minus U17 is left. So it becomes U19 minus U17, which is the right answer. So we have gotten that. We have got the right answer. Therefore, show. So I've shown it. But I've done. Right? So write what U20 would be. And write what U90. U90 would be on subtracting. Right? So this is U90. This in here is U20. And this over here is U90. Right? That is it. We could underline them. No, let's underline them. So it's underline this in red. And that's what we have under here. Underline this one in purple. So we have under here. I'll subtract it. That's it. And number 8. Number 8 is a functions. G of x. This says state what value of x cannot be in the domain. It's a value that will make it undefined. Value to make the delimiter 0 cannot go in there. But the question says what value, say the value of x for its function is undefined, and the same thing I ask you. What value cannot be in the domain? All right? So it's when the function is undefined. This is talking about when f of x is undefined. When that is when f of x is undefined. And that is when denominator equals 0. The denominator cannot be 0. So that value that make the denominator 0 cannot be in the domain. And then it will not be mapped down to anything. Like can't work out. From the fraction cannot work out if the denominator is 0. So that is when x equals minus 1 over 2. If you over 1, you get minus 1 and then divide under the 2. So that is the answer right here. That value of x cannot be in the domain. This cannot be in the domain. So that minus half cannot be in the domain. So it's finding simplest form, the value from f of g. F of g, remember now, it means g into f. Or you put g into f. Take all of this, bring it and put it into the x right here. Into the f right here, let's see. That's why I put g into it. Let me write them down and beat. Let me write them down and beat them. So we have f equals 9 over 2x plus 1. We have g equals x minus 3. And I will put g into f by taking all of the g, bring it down, put it in the f where the x is. Right here. That's our construct f of g. So f of g of x becomes 9 over 2 into x minus 3, where the x was plus 1. Them say simplest term, so we have to simplify this. So it becomes 9 over 2x. 2 times minus 3 is minus 6. Minus 6 plus 1 is negative 5. That's what it becomes. So f of g of x becomes this thing, which is the answer. Very good. That's why I put f into g. I put g into f. G into f as composite function g into f. What is the one? I want f to the minus 1. So f is what again? F is this. And I want f to the minus 1. So f is 9 over 2x plus 1. So f is 9 over 2x plus 1. But the inverse, I'm trying to form the inverse function. So I inverse the f becomes x equals 9 over 2 times. And this x becomes f to the minus 1. F to the minus 1. 2 times f to the minus 1 plus 1. We're trying to make this a subject. So we can do all this denominator multiplied up here and take this x and divide it under there. It's the first step. Trying to isolate the f to the minus 1. So you would get 2 times f to the minus 1 plus 1 equals 9 over x as a first step. 9 over x. The whole denominator multiplied up here, divide it under here. We end up with that thing that I have on the screen. This is subject now. I can subtract the 1 and then divide 2 by 2 or multiply 2 by a half. So subtract 1 first, we're going to get 2f to the minus 1 equals 9 over x minus 1. To get rid of this 2, I can multiply 2 by a half. That's right. I'm just going to multiply 2 by a half. And And that half will cancel this 2. I want to get f to the minus 1 equal, multiply this by a half, I get 9 over 2x. Multiply this by a half, I get half. And now that we're done, we can put it back off x right here as usual. That is the answer. That's not the only way to express it, but that would do it. A single fraction, if I make this into a single fraction, it would be similar. Or I could get f to the minus 1 of x equals 9 minus x over 2x. Out of the multiply this one by x over x, that's all we get 9 minus x on the numerator, all over 2x. I could have gotten that as well. Instead, so I could have got this as well. 9 minus x over x. That's single fraction. All right. That's it. Down here, this question. It said, the diagram below shows 2 rectangles, A, B, C, D. That's this outer one here, so. And G, F, E, F, this inner one inside here, so. So the compound shapes. It says A, B, C, D has an area of 44 centimeters squared. So this is the area of the big one, 44 centimeters squared, right? That's the big one right there. It says by writing an expression for the area of triangle ABCD, show that this thing is true. This equation, show this equation. So the area, that's right here, area ABCD is equal to 44. 44. And what is the area? The area is this length times this length. This length is 3x plus 4. 3x plus 4 is all of that. That's 3x plus 4 times this length. This length is 3x plus 2. 3x plus 2. That's all equal to 44. So this now is supposed to simplify to give you that. Let's do it. I'm going to expand this side first. So it's 3x times 3x is 9x squared. Then 3x times 2 is 6x. Then 4 times 3x here is 12x. Then 4 times 2 right there says 8. That's all equal to 44. Let's consolidate these two and get 18x. So it's 9x squared plus 18x. Then this come over and subtract. Give you 8 minus 44 equals 0. Okay, you know that about 0 on the right side here. So 8 minus 4 is how much? 8, huh? Negative 36. So you get 9x squared plus 18x minus 36 equals 0. Then we're going to divide through by 9, because each of these can be divided through by 9. So to simplify this, we're going to divide through by 9. Let's write it. Divide through by 9. Divide each term by 9. So divide this by 9, I get x squared. Divide this by 9, I get 2x. Divide this by 9, I get negative 4. Divide 0 by 9, it stays 0. That's what they have here. So therefore, show. That's it. You have shown it. Very good. Then they said, calculate 3 decimal places the value of x. So to calculate the value of x, we need to solve this equation. Factor of 4. So this can't factorize. So once I give it the decimal place, it means they can't factorize. A factor of 4, there's no factor of 4, the difference is 2. As factor of 4 is 4 and 1 or 2 and 2. So graph is equal to this moment. Can't factorize. All right. So we have x squared plus 2x minus 4 equals 0. That is the quadratic formula, which is x equal minus b plus or minus the square root. So minus the square root of b squared minus 4ac all over 2a. This equation right here, what's a, the b, and the c? This equation, the a is equal to 1. Right here, coefficient of x squared is 1. The b is equal to this 2. C is equal to this negative 4. And plugging them in this quadratic formula. Right? So the x becomes equal to minus b. B is 2. So you get minus 2 plus or minus the square root. B squared becomes 2 squared minus 4 times a. The a is 1 times c. The c is negative 4. All everything over 2 times a. The a is 1. So that's 2 times 1. Or simplify into x equals minus 2 plus or minus, that becomes square. What is work out now? This becomes a positive 16 and 4. 16 and 4 is 20. So you get 20 over 2 ones 2. So it's working out to 2 values. One with the plus and one with the minus. Let's write them out to the calculator. And it's a 2 decimal places. So the first one, remember, you cannot accept a negative answer. Because the length can negative. Remember, distance can negative. But these x's are distances, right? Distance can negative. So you can't accept the negative answer. So you can always use a positive answer. So the first answer is with the plus right here. It is a fraction, negative 2 plus square root of 20 all over 2. That's 1 point. Them say 2 decimal places, 3 decimal places. Decimal place would be 1.236. And the other one is with the minus. So change that plus 20 to minus root 20 into minus 3.236. But this one is not valid because it's negative. Not valid because it's negative. So this one is the answer. That one is the answer. X equals 1.236 is the answer. One with a plus. All right. It says calculate the perimeter unshaded. The perimeter unshaded. Let's look at the perimeter unshaded on the diagram. I'm gonna list it down here, so, and then add it up, right? So the perimeter unshaded would be this. I want to draw it out. This length, plus this length, plus this length, plus this length across here, plus all of this length up here, plus this length. But I give it that perimeter unshaded with this. I give it perimeter unshaded with that. Perimeter so perimeter square, perimeter unshaded. So I added up all these red sides. This is 3x. Up here, so the same as down here, so 3x plus 2. 3x plus 2. 3x plus 2. The length here the same as over here, so 3x plus 4. 3x plus 4. And this is 3x. So I'm write it up over here. So the perimeter unshaded. Let's put it in blue. So the perimeter unshaded in blue would be equal to, let's add them up. 3x plus 3x plus 2 plus 3x plus 4 plus a 3x here, so. Plus this piece, which is 4, don't it? Plus this 4 right here, so we lift them off a while ago. We have to go all the way around. This side is 4 like this. And this side is 2 like this. We have add them on as well. So we're going to add them on as well. So plus 4 plus 2. That's a perimeter unshaded. Agreed? Make sure. 3x plus 3x plus 2 plus 3x plus 4 plus 3x plus 4 plus 2. All those are added. So I'm going to copy this down and then make it down. That's a perimeter unshaded. Down here. Remember the x is what? In all of this, the x is equal to 1 point. Let's zoom it up. The x is equal to 1.236. That's all in centimeters, right? So when we work this out, find it in centimeters. That's a perimeter shaded. Equal all. Let's add them up. Equals. Let's add the x term. 3x plus 3x, that's 6x. Plus 3x makes 9x. Plus 3x again makes 12x, right? 12x. Plus, add up the numbers them now. 2 and 4, that says 6. And another 6 makes 12. Plus 12. But I get that? See it? Add up the x's. 3x plus 3x plus 3x plus 3x. That's 12x. Add up the numbers. 2 plus 4 is 6. And another 6 makes 12. Plug in the value in us now to get the final answer. So it becomes 12 times 1.236 plus 12. Put that in the calculator. 12 times 1.236 plus 12. So the perimeter shade is 26.832 centimeters. That's the answer. I don't like this question, but see what it is. Perimeter unshaded. Mirror this out and right. All right, perimeter unshaded. That is it. That is the answer. Perimeter unshaded is the area in the red. Unshaded. All right. We are going to another way. Find the perimeter, the whole thing. Oh, leave it at that. But this length is this, and this length is this length. The perimeter, the whole thing same way, you know. But this piece come off of this and gone onto here. This piece come off of here and gone onto there. So it could have been just the perimeter of the whole thing. But then, this is what it is. No problem. It is okay. It is okay. All right, number 9. Number 9 said, diagram shows a circle center, a circle where AC is the diameter. Remember, diameter sub 90 degrees. Remember that? And B and D are 2 other points on the circle. And DEF is a straight line. This straight line is not a tangent. So remember, you cannot use tangent and chord, a tangent and radius on that one. It's not a tangent. It says CAB is 28 degrees right up here, and BBC is 46 degrees right here. All right. All right, let's go on. It says, calculate the value of each of the following angles. Show detailed working where necessary and give a reason for each step in the answer or to support the answer. Angle DBA. So DBA. D to B to E. That's this angle that I want right here. But that angle is part of the angle that is subtended by the diameter. Can you see that? See that? Angle subtended by diameter is 90 degrees. This is 90 degrees. Everything across is 90 degrees. And this right here says piece of that 90 degrees. Let's look at it again. That's a diameter. This diameter is subtending 90 degrees up here. So up here says 90 degrees. They're asking us for this angle right here. If the whole thing is 90, then this angle is 90 minus 46, right? But the angle subtended by diameter is 90 degrees. So that angle is, this angle becomes 90 minus 46 right here. What is that? 44? So that angle is 44 degrees. All right? So this angle is 90 degrees minus 44 degrees minus 46 degrees, which is 44 degrees. The reason for that is that the angle here says so 90 degrees, subtended by diameter. Angle ABC 90 degrees. That's the reason. Reason. Angle ABC equal 90 degrees because angle subtended by diameter is 90 degrees. I'm subtended by diameter is 90 degrees. All right, and that's how we subtract the 46. The whole thing is 90 degrees. Next question. Angle DAC. Angle DAC. Angle DAC. All right. That angle is 46 as well. Oh no. Now angle DAC is up here. Let's work it out in red. This angle right here. Come along the lines forming an angle, you reach this point. Come along here, reach this point. So that angle is subtended by this chord, as you can see. This chord. Same chord is subtending 46 degrees up here. You hear so? Same chord. This chord is subtending 46 up here. So subtend the same amount up here. So that angle is 46 degrees. Same segment rule. Same segment rule. So this angle up here is also 46. Subtended by the same chord. This is 46 degrees up here. Same segment rule. Angles in the same segment are equal. So this angle equals 46 degrees. Reason angles in the same segment are equal when could stop here and could stop right there. Angles in the same segment are equal. We're adding this part. When subtended by the same chord or arc. And those two angles were subtended by the same chord. All right, that's it. Angle BCE next. Angle BCE next. Here's that. Angle BCE. Remember, that's not a tangent, right? So you can't go tangent and chord. So they're asking us now for this angle out here. This angle we want. I say that angle, that's an exterior angle. This angle here that I want is an exterior angle to this triangle. You see that angle now? Because that exterior angle, it is equal to the sum of these two opposite interior angles. It is equal to this one plus that one over here. And the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So we know this one is 46. We need to find this one. But this one is equal to this one up here. Why is that? Because they are both subtended by this chord. So this chord that I'm marking in blue is subtending this angle up here, so, and subtending this angle up here, so. So it means that this one over here is the same as that, 28. So first we're going to say that this angle is 28 degrees. And then this angle out here now is the 46 plus 28. Right? This angle equals 46 degrees plus 28 degrees. Exterior angle of a triangle is equal to the sum of the two opposite interior angles. I think that's the easiest way to do this. Not the only way, but I think that's the easiest way to do it. So it's 46 plus 28. So we tell them this angle is 28 first. So that angle is angle BDC is 28 like this. Same segment. So we tell them that first. So to get this one, first we're going to say angle, that is it, BDC. Angle BDC equals 28 degrees because angles in the same segment are equal. Because angles in the same segment are equal. That's what we have, same segments. These two angles are in the same segment, obtained by this chord, they are equal. And then the angle that I want now is 28 plus the 46. And then the angle down there that I want. Therefore, angle BCE, which is this angle that I want, is equal to 28 degrees plus 46 degrees. Which works out to what? 28 plus 46 is 74. That's because the exterior angle of a triangle is equal to the sum of the two opposite interior angles. That's it. Exterior angle is equal to the sum of the two opposite interior angles. That's how we use it. Right? So that's it. So this angle out here, as I said, is the exterior angle of that red triangle. Extend one side, make the angle with extension. With the arm, the adjacent side, you have an exterior angle. It's equal to the two opposite interior angles, 28 and 46. That is that. Say it is 44, 24, plus 24 degrees. Right? That finishes that. Then we come to this question, sine rule and cosine rule question. You can see it. That triangle. Question said, diagram below shows quadrilateral PQRS, PQ and PRR parallel. Put on the line, put on arrows on them for the parallel. And once you have parallel line, you think of U angles and Z angles. Z angles are equal U angles, what you call co-interior angles, they add up to 180 degrees. So PQ up here is parallel to SR down here. Let's put R on them. So this side parallel. So you put arrows on them to give that indication. So it means that you have a Z right here. So this angle and this angle is the same. Z angles, right? So if I put it in from now, this angle is 30 degrees. And if this is 90, then these two are up to 90. So they only say 60 degrees. All right. Question says, find the length of PS. Give us this as 8. Another one, the length of PS right here. So you can either work with the 60 or the 30, your choice. If we work with the 60, then this is the adjacent. And let's say we're going to work with the 30. Let's say we're going to work with the 30. Let's leave the 30 and work with the 30. So to the 30, this becomes the opposite. This becomes the adjacent. And this is the hypotenuse. But the hypotenuse is always opposite the 90. All right? So we're going to work with the 30 as a reference angle on a consideration. And we're trying to find PS. So we want the opposite and we know the hypotenuse. We're going to use sine. Sine of 30 degrees. Sine of 30 degrees equal the opposite side, which is PS, over the hypotenuse, which is 8. The data multiplied across here, you're going to get that PS equals 8 times the sine of 30 degrees. Sine of 30 degrees is a half. So PS equals 4 centimeters, because the sine of 30 is a half. I know that. So PS is 4 centimeters. Let's put another. PS is 4. So this side equals 4 centimeters. Then we want to find the length of PQ. So for PQ now to this side, you can use Pythagoras theorem if you want, because you know two sides. It's Pythagoras theorem, or you can use cos. Find this side. Your choice. Now use cos equals adjacent to hypotenuse. Same. Let's just use cos. So two ways. You can say PQ equals the square root of 8 squared minus 4 squared using Pythagoras theorem. Work it out. Or we could say the cos of 30 degrees equals adjacent PQ over the hypotenuse of 8. Take it and multiply it up here, so you get PQ equals 8 times the cos of 30 degrees. Whichever method they use, you're going to get the same thing. PQ equals, let's show it. If we do the 8 cos of 30, that's what we get. 8 times the cos of 30 degrees, you get 6.93. 6.93 centimeters. If you do this workout, you're going to have the same thing for this workout. It is part of this theorem. Square root of 8 squared minus 4 squared. So you get the same thing. 6.93 centimeters. So your choice. All I did up here was use part of the theorem. This side is the square root of the hypotenuse squared minus this side squared. That's a right angle triangle, so we could use that. Or we could use cos equal adjacent over hypotenuse. You can also use tan if you want. Tan of 30 equals opposite over adjacent. All right, so you have all those options. All right, in any case, the length of it is 6.9. Then I want the area of PQRS. PQRS, the whole thing. I want the area of PQRS. All right, so find the area of PQRS. It's a trapezium, you know. That's a perpendicular distance between them. So we want to find this length. In order to find the area, we need to find this length. So we're going to use the trapezium formula. Half the sum of the two parallel sides times the distance between them, which is that. So we need to find this length down here, so RS. So to find RS now, we're going to use what? We can use sine rule, this triangle. This angle with this side And this angle down here, so with this side, we need to find this angle under here. So what will be this angle be? This angle inside here, let's put under the angle. The 180 minus these two. This angle to the 180 degrees minus the 30 and the 82. That's what this angle will be inside here. It's 180 minus 30 minus 82. That's 68 degrees. So to find this side, I'm going to use sine rule. And then once you use sine rule, I find this side, I'm going to use these two sides of the two parallel sides in the trapezium, and this is the distance between them. That's what I want to do. So let's find this side first, SR, using sine rule. Down here. To find here, I need SR first. So sine rule for SR. Sine rule for SR. So remember, SR over sine of the angle opposite the SR. Angle opposite the SR is what? Angle opposite the SR is 82 degrees. And then we're going to use 8 over tan of 68. So it's this two with these two in the sine rule. All right, so it's SR over sine of 82 equals 8 over sine of 68. So SR over the sine of 82 equals 8 over the sine of 68. All right, that's it. I'm going to take now the S sine of 82 and multiply it up here and get SR. So SR equals 8 times the sine of 82 degrees over the sine of 68 degrees. So SR equals, I wrote that out. So it's going to be fraction 8 times sine of 82 over the sine of 68. So I get 8.54 centimeters. Now one of the air trapezium now. So the trapezium is like this. Short side, side like that, and long side like that. Up here, so what is the we get the side as 4. We get the top side as the adjacent was what? So this side is 4. The adjacent PQ was it's a PS and a P. It's a PS. This is PS. So PQ was what again? PQ was 6.93. 6.93. This is 6.93. That's the trapezium that we're doing, right? That's the trapezium. We'll just get this side over here. So SR would be this distance, 8.54. This is 8.54. That's the trapezium. All right. So the area now. Area becomes half the sum of the parallel sides. It is 6.93 plus 8.54. And the distance between the parallel sides is 4. That gives you the area of the trapezium. And let's leave it upon it. It was EQRS. EQRS is EQR. Area of PQRS becomes that trapezium. So 90 and that was 90. All right? So from those sides. So we're going to work it out now. So it becomes half to 0.5 times bracket. So the parallel side 6.93 plus 8.54 close bracket and the distance between them is 4. That's 30.94 centimeters squared is the area of that piece. All right, one last question. One last question. Guys, anything we get wrong, we shouldn't go and work them over anymore. Work them over again. Go and do them over. All right? You shouldn't work over the question. It's the answer for it. Had to work out SR, needed SR. So you sine rule. All right? You sine rule. The triangle up here, you sine rule. This triangle. You sine rule of this triangle. All right? These two, that's the SR that I want to. Right? These two. I had to find the angle of 68. I had to use a sample. All right, next question. Next, I think I'm going to start a question from the back. You guys look tired. You need to pay attention to this question. Last question. Find the matrix product. This time this. Just multiply these two matrices. Remember, in multiplying two matrices, you multiply the rows of the first matrix with the columns of the second matrix. But it's just one column. This multiplication is going to give you a column matrix. It's going to be equal to one column matrix with two values here and there. This first value is positioned in first row on the one column. So to get to multiply this first row by this one column. Then you multiply them. First element times first element, second element times second element. First element times first element, second element times second element. Minus 1 times k and 3 times 5. The minus 1 times k is minus k. And the 3 times 5 is 15. So it's minus k plus 15. Then, the value down here at 1 is in the second row and the one column. So to get it to multiply this second row with this one column, we multiply them. First element times first element, second element times second element. First element times first element, second element times second element. So it is 4 times k and 8 times 5. 4 times k is 4k. 8 times 5, same as 5 times each, which is 5 each. Let's always back that a little bit more. That's the answer right there. Let's simplify it. Equals. Let's write it as 50 minus k instead. And this make it stay as 4k plus 5e. One column vector. That is the answer right there. All right. Next part says, find the value of h and k if this product equals 0. 0, 0. So if the product equals 0, means that this equals 0, 0. So that's a therefore 50 minus k and 4k plus 5h is equal to 0, 0. Zoom up. It means that this thing equals 0. That's what it means. It's with a different color. Therefore, 50 minus k is equal to 0, which implies that k equals 15. Like our k gets 15. And then we said this equals 0 as well. And 4k plus 5h equals 0. But the k is 15 right here. So we can say that is, this tells us that 4 times 15 plus 5h is equal to 0. And that is what? We divide by 5, we get 12. That gives you h equals negative 12. The answer. H equals negative 12. Because it's a 60, you know. And the answer is 0. This is going to be 60. It's going to be negative 60. It's going to be negative 60. In order for it to be negative 60, the h is going to be negative 12. So those are the two answers right here. K is 15 and h is minus 12. Those are the answers right there. Let's continue. matrix method to solve this pair of simultaneous equation. So first, I will write the matrices equation, which is a 2 by 2 matrix times a column matrix with x and y. Why? Because x followed by y in the first equation, x followed by y in the second equation. That equal a column matrix with these two values, 5 and 13. And this matrix now takes the coefficients of the values, these two equations, is 2 and 3, 2 and 3, minus 5 and 1. That's just a y, it says a 1y, it says minus 5 and 1, minus 5 and 1. You try to find xy front here. So xy is going to become the inverse of this matrix, 2 minus 5, 1. Let's put the inverse on it in red so we can see it. So minus 1, that's the inverse of this matrix. The inverse will multiply by 513. So we have to work out the inverse of this matrix now, so we can complete the calculation. So x becomes equal to, what's the inverse? 1 over the determinant. The determinant plus this product is 3 times negative determinant. 1 over the determinant, which is this time this is 2 minus this product is 3 times minus 15. It becomes a plus. This works out to be 17 under here. It becomes 17. That's the determinant. Then now multiply by that joint. To that spot. All right. I have to share this again. I have to share this again. All right, and we're back. Yep, we're back. All right, so as I said, now I'll leave this fraction out here for last of 1 over the determinant. That's 1 over 17. And I want to do this calculation here. So remember to do this calculation again, you multiply these two rows by the one column. All right, and you're going to get a column vector, column matrix again. With the same, with the two values here again. Same calculation as we did before. So then this row times this column first to get this. The same thing we did a while ago. 1 times 5 and minus 3 times 30. 1 times 5 is 5. And minus 3 times 13 is minus 39. And this value is this row times this column. So it is 5 times 5, 2 times 30. So the 5 times 5 is 25. And the 2 times 13 is 26. So that reduces to xy equals, it's become negative 34, 1 over 17, negative 34. This becomes how much? That becomes 61. No, 51. 51. This you get nice multiples of the 17. That's the beauty about this. Get multiples of the 17. So xy equals negative 32, negative 34 divided by 17 is negative 2. And 51 divided by 17 is 3. Don't stop this. All right. Therefore, x equals negative 2, y equals 3. Y equals 3. Those are your answers right here. That's the calculation. Your question addition is not even supposed to happen. I set this all the time, the routine question, almost. Not finished yet. Still have a last part. Question said, relative to an origin O, the portion vector of A and B are 9, 0. That's this vector out here is 9, 0. That's the horizontal vector. No vertical component. A vertical component is here. So it's the horizontal vector that. And 3, 6. This is 3, 6. That means 3 this way, 6 up so. All right? It's kind of easy. It says the point D and E are on AD and OE respectively and are such that AD is 1/3. AD is 1/3 of AB. So AD is 1/3 of AB. Good. So this is 1/3 of the whole thing. All right. And OE is 1/3 of OA. So this is 1/3 of all of them. All right. So we can know this one right away because if all of this is 9, then right here says 3. So this point is going to be 3, 0. That's 1/3 of the whole way. That point is 3, 0. It says express in the vector form AB. Like that, the vector AB first. Now, vector AB is simply OB minus OA. O times the last minus O times the first. OB minus OA. O times the last minus O times the first. And the OB is this, 3, 6. Minus the OA is this, 9, 0. That becomes negative 6, 6. It means to go from A to B. Minus 6 is 6 this way. And 6 up here, so which kind of makes sense. Right? That's negative 6, 6. We go from A to B. Remember that OD now is 1/3 of the AB. You cannot literally work over the AD is now. Right? So the one OD. All right, the one OD. So you can look at it and how do we go from O to B? You can go O to A first and then A to D. You can look at it that way. Let's do it that way. You go from O to D, you can go from O to A and then A to D. But the AD is 1/3 of AB. So this is O to A and then 1/3 of AB. So the AB again, minus 6, 6. So put in the value. What is the OA again? OA is 9, 0 plus 1/3 of negative 6, 6, which is 9, 0 plus, within 1/3 of this, you get minus 2, 1/3 of this, you get 2. So the final answer is 9 and minus 2 is 7. 0 plus 2 is 2. So OD is 7, 2, which kind of makes sense as well. See? 7 this way and 2 up. Makes sense. 7, 2. Right? What else? BE. Let's look at the diagram. BE. Went from B to E. That's just minus 6 now. They're going to come down by 6. That's just negative 6. That's just 0, negative 6. Looking at the diagram to go from B to E, we can use OB minus OE, because OE is 30. OE is 30. So we can use OB minus OE. All right? So BE is, no, not OB, OE minus OB. Remember the E was a 0.30 and the B was a 0.36. So it becomes OE will have the same value as that, which is 30, minus OB will have the same value as that, which is 36. So the 3 minus 3 is 0. 0 minus 6 is negative 6, which makes sense because to go from B to E on this diagram, let's go 6 down a row. 6 down. I don't have the same X value. So let's go 6 down. So we get the negative 6. This answer makes sense. And they were all very easy. End of this test. And that is that. That was fun. Don't. Of course that was fun. You know it was fun. Must enjoy doing the maths, you know. Wanna go and I want you much to get. Wanna talk about. Come here, youngster. I want you how much to get in. Every day I get up and I leave. From today in sport, I must know how much to get on the paper. Mark the paper and how much to get. While I'm doing it, you're marking and calculating a grade. I want to know how much you got on the paper. You're all just sitting and doing it on Saturday. Come, sit down with me how much to get. Check for the market. Check for the good paper around it. Let me know how much to get. Huh? Why don't come on the paper? Listen, don't run for me, you know. Is it from now? Every class on the paper, more how much to get. Go run for me. Well, you're not going to have Thursday, more how much to get Thursday. Thursday, I'm going to do a paper, and we'll mark at the same time. Huh? When I do the paper, I'm going to answer and I'm at the same time I'm going to leave. Welcome Wednesday then. Huh? What are about time for? No one passing the exam. How about time, boy? Students online, remember what I just said. Next, every paper after this, I need to know how much I get. So you're doing a paper on Wednesday and a paper on Thursday. Give me the answers and tell me how much I get same time before you leave. Same thing on the weekends. I need to know how much you're getting. All right? All right, that's it, guys. See you Wednesday. And I'm going to send a video in the group. They can look back and check that you did not get right. What you did not get right. Bye.